U.S. Space Force launches X-37B Mission 8. Laser communications, quantum sensors. The U.S. Space Force is gearing up for an exciting milestone as it prepares to launch the 8th mission of the X-37B Orbital Test Vehicle, OTV-8, on August 21, 2025, from the iconic Kennedy Space Center in Florida. This mission, a collaboration with the Air Force Rapid Capabilities Office, promises to push the boundaries of space technology and exploration. The X-37B Mission 8 will be propelled into orbit by a SpaceX Falcon 9 rocket, known as USSF-36, and will focus on a diverse array of testing and experimental objectives. Among these are groundbreaking technologies such as advanced laser communications and the most sophisticated quantum inertial sensor ever tested in the vastness of space. Key partners in this mission include the Air Force Research Lab and the Defense Innovation Unit, both of which play crucial roles in the development of these technologies. One of the primary goals of Mission 8 is to enhance the resilience, efficiency, and security of U.S. space-based communication systems. This will be achieved through laser communication demonstrations that utilize a network of commercial satellites operating in low Earth orbit. Laser communications are set to revolutionize space communication. The shorter wavelengths of infrared light allow for a significantly higher volume of data to be transmitted with each signal. Moreover, these systems offer greater security compared to traditional radio frequency communications, thanks to the focused nature of laser beams. By employing a network of relay satellites, the U.S. can ensure that its space architecture is robust and free from single points of failure, thereby increasing overall resilience. These experiments are part of a larger initiative by the U.S. Space Force to safeguard the space domain and enhance the adaptability of its orbital systems. General Chance Saltzman, Chief of Space Operations, emphasized the importance of this demonstration, stating, "The laser communications test of OTV-8 represents a significant advancement in our ability to utilize proliferated space networks, contributing to a more diverse and redundant space architecture. This will ultimately bolster the resilience, reliability, adaptability, and data transfer speeds of our satellite communications." In addition to laser communications, Mission 8 will showcase the world's most advanced quantum inertial sensor ever deployed in space. This innovative technology will enable precise navigation without the need for satellite networks, such as traditional GPS, by detecting the rotation and acceleration of atoms. This capability is particularly valuable in environments where GPS signals are unavailable, enhancing the navigational resilience of U.S. spacecraft against both current and future threats. Furthermore, quantum inertial sensors hold the potential to revolutionize navigation in cislunar space, paving the way for advancements in long-distance space travel and exploration. Colonel Ramsey Horn, commander of Space Delta 9, remarked on the significance of the quantum inertial sensor demonstration, stating, "The demonstration of OTV-8's quantum inertial sensor is a crucial step towards operational resilience in space. Whether navigating beyond Earth's orbits in cislunar space or in GPS-denied environments, this technology provides robust navigation capabilities when traditional GPS is not an option. Ultimately, it plays a vital role in our operations within the 5th Space Operations Squadron and across the Space Force, ensuring movement and maneuverability even in challenging conditions. The 5th Space Operations Squadron, part of USSF Delta 9, is responsible for the daily operations of the X-37B in collaboration with the Air Force Rapid Capabilities Office. The X-37B itself is a versatile and agile spacecraft, designed to conduct a variety of tests and experiments that accelerate the development of essential next-generation technologies and operational concepts for reusable space capabilities. As we look forward to the launch of Mission 8, the implications of these advancements could reshape our understanding and utilization of space. Exploring the X-37B, the Secretive Spaceplane, testing quantum navigation. Imagine a world where navigation in the vastness of space is revolutionized. Soon, the U.S. Space Force's enigmatic spaceplane, the X-37B, is ready to embark on another significant mission that could alter how we traverse the cosmos. On a recent Monday, the Space Force announced that the 8th mission of this remarkable spacecraft is set for launch next month. Scheduled for no earlier than August 21st, the X-37B will ride a Falcon 9 rocket into space, departing from the historic Kennedy Space Center in Florida. Did you know there are currently 2 active X-37B models in the Space Force's lineup? Designed by Boeing, these uncrewed vehicles, each approximately 29 feet, 9 meters long, and about 1/4 the length of NASA's Space Shuttle orbiters, first took to the skies in April 2010. Over the years, they have completed an array of extended flights, with the first one achieving its remarkable record of 908 days in space from 2020 to 2022. The second X-37B landed at Vandenberg Space Force Base on March 7 after orbiting for 434 days, showcasing impressive endurance. What can we expect from this upcoming flight? While the Space Force has previously kept the specifics of the X-37B's missions under wraps, they're sharing more about the latest endeavor, OTV-8. This mission will see the spacecraft equipped with a service module, enhancing its experimental capabilities. Notably, it will host payloads developed by the Air Force Research Laboratory and the Defense Innovation Unit, aiming to test cutting-edge, high-bandwidth inter-satellite laser communications technologies. General Chance Saltzman, the Chief of Space Operations for the U.S. Space Force, emphasized the importance of the laser communications demonstration, stating that it represents a significant advancement in utilizing commercial space networks. This effort aims to build a more diversified and resilient framework for satellite communications, enhancing the overall reliability and transport speeds of this essential infrastructure. But here's where it gets interesting. The X-37B isn't just focused on communication. It will also be at the forefront of experimenting with a groundbreaking navigation technology that utilizes electromagnetic wave interference. The Space Force's announcement describes this as the highest-performing quantum inertial sensor ever tested in space. Previously, Boeing had tested a quantum inertial measurement unit capable of detecting rotation and acceleration through atom interferometry on traditional aircraft. Now, an upgraded version of this technology is set to demonstrate its effectiveness in space, targeting issues like precise positioning and navigation in areas where GPS is either compromised or unavailable. General Saltzman highlighted the critical nature of these tests, pointing out that this technology could be invaluable for military operations in contested environments where GPS signals may be weak or entirely blocked. He even mentioned applications for lunar explorations or missions venturing deeper into the solar system, where GPS simply doesn't exist. As a side note, this mission will see the X-37B returning to a medium-lift rocket for the launch, after previously utilizing a Falcon Heavy rocket to achieve a higher elliptical orbit. This transition demonstrates the versatility and adaptability of this remarkable space vehicle. Given the secretive nature of the X-37B and the ambitions surrounding its missions, questions arise. What will be the implications of successfully implementing quantum navigation technology in various space endeavors? Will this pave the way for a new era of exploration? Share your thoughts. Do you think these advancements will impact navigation beyond Earth? Let's dive into this discussion. U.S. military X-37B spaceplane prepares for 8th mission. The anticipation is building. The U.S. military's enigmatic X-37B spaceplane is gearing up for its 8th mission, a milestone that continues to captivate space enthusiasts and defense analysts alike. This secretive spacecraft, often referred to as the Orbital Test Vehicle, OTV, has sparked curiosity and debate since its inception. Now, the U.S. Space Force has officially announced a launch window for this next chapter in its storied journey. Mark your calendars. OTV-8 is set to blast off no earlier than August 21st from the iconic Kennedy Space Center in Florida, riding atop a SpaceX Falcon 9 rocket. But here's where it gets intriguing. Despite its frequent missions, much about the X-37B remains shrouded in mystery. For those unfamiliar with the program, the X-37B is a reusable, unmanned spaceplane developed by Boeing. It's essentially a miniaturized version of NASA's retired space shuttle, but with a more classified purpose. While its design might resemble something out of a sci-fi movie, the X-37B serves very real and highly sensitive missions for the US military. These missions are thought to involve testing advanced technologies, conducting experiments in space, and potentially supporting national security objectives. However, the exact details of what happens during these flights are rarely disclosed, leading experts and the public to speculate about its true role. This upcoming mission, designated OTV-8, marks another step into the unknown. The fact that it's being launched aboard a SpaceX Falcon 9 rocket adds an interesting layer to the story. SpaceX, known for its groundbreaking work in commercial spaceflight, has become a key partner for government-led initiatives. This collaboration highlights how public-private partnerships are reshaping the future of space exploration and defense capabilities. Yet this raises questions worth pondering. How does the integration of private companies like SpaceX impact the transparency, or lack thereof, of military space programs? And should taxpayers have more insight into how their money is being spent on such secretive endeavors? Sandra Irwin, a seasoned journalist who specializes in military space programs, sheds light on these issues through her insightful reporting. With nearly 2 decades of experience covering the Pentagon, Congress, and the defense industry, Irwin has established herself as a trusted voice in this complex field. Her work provides valuable context for understanding not just the X-37B program, but also the broader landscape of military space operations. For readers eager to dive deeper into her expertise, additional articles authored by Irwin can be found online, offering a treasure trove of knowledge on everything from policy developments to cutting-edge technologies. But let's circle back to the heart of the matter. Why does the X-37B command so much attention? Part of the answer lies in its dual nature. It's both a symbol of innovation and a source of controversy. On one hand, the spaceplane represents the pinnacle of modern engineering, pushing the boundaries of what's possible in space. On the other hand, its clandestine operations fuel skepticism and conspiracy theories. Some critics argue that the lack of transparency undermines public trust, while others see it as a necessary measure to protect national security interests. Where do you stand on this issue? Is secrecy justified when it comes to safeguarding technological advancements, or should there be greater accountability? If you're intrigued by these questions and want to stay informed about the latest developments in space exploration and defense, consider subscribing to newsletters that provide regular updates. For instance, Space News offers a weekly digest called Space News This Week, delivered straight to your inbox every Friday. Subscribers gain access to exclusive content, including in-depth analyses and breaking news stories. Best of all, new users can register for free to enjoy 3 complimentary articles per month. Of course, if you find yourself craving unlimited access, affordable subscription plans are available, starting at just $5 per week, billed quarterly. You can cancel anytime, though many find the insights gleaned from these reports invaluable. In the end, the X-37B's 8th mission is more than just another launch. It's a reminder of humanity's relentless pursuit of progress, even in the face of uncertainty. As we look to the stars, we must also grapple with the ethical, political, and societal implications of our actions. So, what are your thoughts? Should space-based military programs prioritize secrecy over openness? Share your perspective in the comments below. We'd love to hear from you.